Alright guys, we're going to wrap up the test prep questions from 9.1 through 9.3 by doing 9.3. From each of these sections, there are 2 questions. So this is from 9.3 day 1, 2 from 1 through 9, 2 from the 10 through 18, and then 2 from the final section. We did the 19 through 24. Excuse me. Okay, so this one says find any point of discontinuity for the rational function. Well, what's great about a point of discontinuity is that we don't care about the numerator at all. The only thing we care about is the denominator. So I'm going to take a look at number 6, for example, and we have y equals x squared plus 4x plus 3 all over 2x squared plus 5x minus 7. Well, this isn't going to matter. It's not going to change the point of discontinuity. So I'm only looking at the denominator. So 2x squared times negative 7 is going to give me negative 14x squared. Then I want to take my middle value, and in this case it's 5x. Are there factors of negative 14 that when I add them together, it would give me 5? And in this case, that would be 7x and negative 2x. Because 7 times negative 2 is negative 14. 7 minus 2 gives me 5. So now, using our box to help us find our least common factor, the greatest common factor, I should say, your a term goes here, and that is 2x squared. The c term goes down here, and then the factors that you found here are going to go in the opposite diagonal. So then you have 2x squared and 7x. They have an x in common. Negative 2x and negative 7 have a negative 1 in common. 2x squared and 2x squared have 2x in common. 7x and negative 7 have 7 in common. Okay, so then our denominator, like I said, don't really care what's in the numerator. We have 2x plus 7 times x minus 1. And now what I need to do is set each of those equal to 0 and solve for x. So then you have 2x plus 7 equals 0 and x minus 1 equals 0. So subtract 7, and you have 2x is negative 7, and then divide both sides by 2. And then over here, add 1, and you have x is 1. So our points of discontinuity for number 6 are negative 7 over 2 and 1. And that's it. Pretty awesome. All right. From the second section that we did for the homework, you're going to have 2 questions here. And this one says, describe the vertical asymptotes and holes for the graph of each rational function. All right, so let's do 2 of these. So let's say I'm looking at number 12. Y equals x plus 3 over 2x plus 3 times x minus 1. Well, this x plus 3 does not have a partner down in the denominator, so then that means I do not have a hole. But I would have vertical asymptotes. Holes are when we have the expressions in common in the numerator and denominator. And in this case, that doesn't exist. So then you have vertical asymptotes at 2x plus 3 is 0, and x minus 1 is 0. So you would subtract 3, and 2x is negative 3, and then divide both sides by 2, and so then you have x is negative 3 halves. Add 1, and you have x is 1. So we have vertical asymptotes at x is negative 3 halves, and x is 1. All right, oops, not what I wanted, but that's okay. Now let's take a look here at number 13. So we have x minus 2 in common for both the numerator and denominator. So this one is going to create a hole, and then this x plus 1 does not have a partner in the numerator, so this one is creating a vertical asymptote. So you have a hole at x minus 2 equals 0. So you add 2, and you have x is 2. And then you have a vertical asymptote at x plus 1 equals 0, and you subtract 1, so then x is negative 1. So you have a hole at x is 2 and a vertical asymptote at x is negative 1. All right, and then the third section that we had done in the last section from this test prep, it says find the horizontal asymptote of the graph of each rational function. All right, so this one does not have anything that we're adding to, and that's what was confusing with comparison to 9-2. But remember, if the degree of the numerator, and the degree means the exponent of your variable. So if the numerator is greater than the denominator, and it's the degree, I should say, the degree of the numerator is greater than the denominator, then there is no horizontal asymptote. If the degree of the denominator is greater than that of the numerator, then this one has a horizontal asymptote of y equals 0. If the degrees of the numerator is equal to the degree of the denominator, then your horizontal asymptote is y equals a over, b. All right, so real quick, let's take a look at 23. You have 5x cubed is the leading in the numerator. 2x to the fifth is leading in the denominator. So all you do is inspect these two. 5 is greater than 3. So that means that the denominator, the degree of the denominator is greater than the degree of the numerator. And if the degree of the denominator is greater than that of the numerator, then you have y equals 0. So you have a horizontal asymptote of y equals 0. We'll look at 21. Both of these have degree 1. So that means the degrees are the same. So your horizontal asymptote is going to be 1 over 1, which is just 1. All right, look at 24. Here's the terms that we're looking at. They're the same degree because that's degree 1, degree 1. So then your horizontal asymptote is just your coefficients. And there you go. All right, that's a wrap. Hopefully, like I said, I know it's not as good as me being there in class in person, but hopefully this is a close second. Remember, if you have any questions, please email me before Thursday night.